Hello everyone, thank you for joining me today. My name is Minam and today we're going to be looking at upthrust. So we only have a couple of learning objectives and they are to be able to define upthrust and to understand the process of upthrust. So let's get right into it. Now, we want to understand what upthrust actually is. So let's first have a look at this boat over here. So we can see that the boat is just there in the ocean and it's floating. That's a very important point. And we know that everything has a weight and that weight is always acting downwards towards the center of the earth. And so that's our weight there. But for the boat to actually float and stay still, to be in equilibrium, we would need an equal and opposite force acting upwards against the boat. That is called upthrust. So that's what we're going to be looking at today. And upthrust is really nothing but the weight of the fluid, which in this case is seawater, displaced. Okay, so this really simple definition really actually means quite a deep thing. So this really tells us why certain things float and why certain things don't float. Really and truly, to have something float, the weight of the fluid being displaced by the object has to be equal to the weight of the object itself. So that means that if the density of object is greater than the density of the fluid, this means that that object will actually never displace a large enough volume to actually weigh enough to actually counteract its own weight. That's because it's more dense. Because it's more dense than actual water itself. Let's say 1 meter cubed of the substance, right? So say iron or whatever, and 1 meter cubed of water. We know that because the iron is more dense, 1 meter cubed of iron weighs more than 1 kilogram of water. So no matter how much volume of iron you actually have, the weight of the water being displaced by that volume of iron will never be enough to actually counter the weight of the iron. I realize it's all a bit over the place, but again, if you work through logic, you will understand this. This is often why boats, so if I take a cross section of a boat, they often have huge empty spaces, which are really called, I think they're called buoyancy rafts, something like that. They have huge empty spaces inside to match. So that means that where the boat sits in the water, right? All of this area of the boat, even though the frame of the boat is made out of aluminium or whatever, the overall density of that area of the boat ends up being the density of the fluid, which is a really seawater, right? Which is around a gram per centimeter cubed. So, and because of all of this empty space, air is much less dense than actual water. So that sort of less density of air and the heavier density of the actual metal itself sort of counteracts, and so we get an overall density equal to the seawater surrounding. Okay, so now we really understand upthrust and the process of upthrust, being that for an object to float, the weight of the fluid being displaced by that object has to be equal to the weight of the object itself.